given set A is equal to all values of x less than or equal to 2, set B is equal to all values of x that are greater than -1, and set C is equal to all real values of x such that x is less than -3. Find, part A, set A intersect set B, and part B, set B union part C, and in both cases use graphs to do this, use graphs. Okay, the good news is our inequalities are already in their simplified form. In other words, the x's are isolated on the left side of the inequality sign. So part A, we're going to graph set A and B, and then we're going to take the intersection of the two sets. And first we have the number line representing set A, the number line representing set B, and then the number line on the bottom will be representing the intersection A intersect B. We're going to line up the numbers directly on top of each other. First we're going to have the -1 because it's smaller, and then we're going to line up the number 2 because it's greater. Those are the only interesting numbers between set A and B. Okay, so here we're shading everything that's less than or equal to 2, that's set A. And for set B, we're shading everything that's greater than -1. Not equal, but just greater than. Now in A intersect B, the line on the bottom, we're going to include only elements that are shaded in both set A and set B together. That doesn't happen for any values smaller than -1, and it doesn't happen for any values greater than the value 2. For values between -1 and 2, yes, all of those values are shaded in both of the sets A and B, so they will be included in this intersection. We're going to put a round bracket on the -1 and a boxy bracket on the 2. Boxy on 2 because we have to include 2 since it lives simultaneously in set A and B above. And a round bracket on -1 in the intersection because we must exclude x equals -1 since it's only included in the top set A and not in set B. So there's I'll put a box around this graph. This is a picture of our solution, the graph. Now the set form of that answer, curly set bracket, all real x such that it's between -1 and 2, so put -1 less than x less than or equal to 2 because we include the 2 with the equal portion. And for the interval notation, we have the round bracket for -1, the smallest value, comma, the largest value shaded in the picture, the graph of the solution is the number 2, and it has a boxy bracket since it's included in this set, so it gets a boxy bracket on the interval form, everything from -1 to 2. Part B, now we're going to do part B, that's set B union set C. So we're going to first graph the set B and the set C on stacked number lines, and then on the number line below we'll take the union and graph the union. So first we write set B and draw the x number line, and then set C, draw the x number line, and then the union B union C number line right below. Now the important numbers here are -3 and -1. We're going to stack those numbers up, the smallest one on the left, the largest one on the right. For set B, we're going to shade all the values that are greater than -1, but not equal to -1, so it gets a round bracket. For set C, we're shading everything smaller than -3, but not equal to -3, so a round bracket. In the union, B union C, we take all elements in B together with all the elements in set C. Okay, so for values of x that are smaller than -3, that's included in set C, so we will include that in the intersection, the union, and then also the values greater than -1. But you know what's happening between -3 and -1? Absolutely nothing. Nothing is happening in either of the sets. That's why there's no shading in the union. Only values that appear in either set B or set C will be included in the union. We put round brackets on the -3 and the -1 because we need to exclude them. They do not live in either set B or C. If you look very closely in set B, there's no -3 at all, and -1 has a round bracket, so neither of those are included there, nor in set C, which has a round bracket at -3 and nothing at -1. Okay, set notation for this graph, all real values x, such that x is less than -3, union together with x greater than -1. And for interval notation, we have a split interval here on the left of the boxed intersection that we just drew. We have the smallest value is negative infinity with a round bracket, comma, the largest value is negative 3 with a round bracket. Union that interval together with the smallest value in the second interval, open interval round bracket for negative 1, all the way out to infinity round bracket. And those are our solutions. They all say exactly the same thing.